All right, today we're going to unlock the invisible architecture that pretty much powers our entire digital world, the database management system. It's a piece of tech you use literally every single day, probably without ever thinking about it.
Okay, so picture this. You're trying to find one specific book in a massive library, millions of them, but there's no catalog, no index cards, no librarians to help, just endless, disorganized shelves. That chaos, that's a perfect snapshot of what our digital world used to be like before a new system came along and brought some serious order to it all.
So to really get why this new system was such a big deal, we have to understand the problem it was built to solve. Let's go back to the beginning, to the age of data chaos.
Way back when, before we had these slick, organized databases, everything was handled by something called a file processing system. Think of it this way. Every department in a company, accounting, sales, HR, they all had their own separate digital filing cabinet. Each one was its own little island of data, completely cut off from the others. And this comparison, it really tells the whole story. It's the before and after. On one side, you have the file system, which was just chaos. Information was copied everywhere, it was isolated, it was totally inconsistent. And on the other side, you've got the database management system, or DBMS. It promised order, security, and reliability. This was the massive shift that had to happen. I mean, this old system was just fundamentally broken. You had massive data duplication, which wasted a ton of resources. Information was trapped, so the sales department couldn't easily see what a customer in the support department's files was up to. This led to some really obvious problems, like inconsistencies. You update an address in one file and it stays outdated in 5 others. On top of all that, security was a joke. And if 2 people tried to access the same file at the same time, well, you could end up with corrupted data. It just wasn't sustainable.
So, out of all this chaos, a new solution finally started to take shape. It was time to bring in a manager, someone to get all this unruly data under control.
And here it is, the Database Management System, the DBMS. Put simply, it's the software that acts as a smart gatekeeper for a central collection of data. It's not just a storage box. It's a really sophisticated system for managing the whole shebang, from creating the database in the first place to securely pulling out one tiny piece of information.
And this system directly tackles all those problems we just talked about. It handles security, controlling exactly who gets to see what. It manages multi-user access, so lots of people can work at the same time without messing up the data. It enforces what's called data integrity, which basically means if you update an address in one place, it gets updated everywhere. And, super important, it handles backup and recovery, protecting all that precious data from disaster.
But here's the thing, a manager is only as good as their plan, right? A DBMS needs a blueprint for how it's actually going to organize all that information.
And that blueprint has a name. It's called a data model. It's the logical structure that defines how all the data is connected, how it's processed, and how it's stored. It's the thing that turns a random pile of facts into a coherent, searchable library.
Now, these models have changed over time. The early days saw what was called the hierarchical model, a very rigid tree-like structure. Think of a family tree where each piece of data had only one parent. Then came the network model, which was a bit more flexible. It let data have multiple parents, kind of like a social network. But the real game changer, that was the relational model.
And this is it. This is the model that powers so much of our modern world. The relational model organizes data into simple two-dimensional tables, just like a spreadsheet. You've got rows, you've got columns. And this beautiful simplicity is what made it so powerful, so flexible, and so easy to scale up.
So now we have this powerful, super organized system. But for the average person using it, it's still incredibly complex under the hood. The next brilliant idea was to just hide all that complexity.
As one of the foundational books on this topic puts it, the goal is to provide users with an abstract view of the data. What does that mean? It means the system does all the heavy lifting in the background, hiding all the messy details of how and where the data is physically sitting on a hard drive.
This is done through 3 different levels. At the very bottom, you have the physical level. That's the super complex, nitty-gritty stuff about how bits and bytes are stored on a disk. Above that is the logical level, which describes what data is being stored in those tables we just saw. But most of us, we only ever deal with the top layer, the view level. It just shows us the small slice of the database we actually need to see in a really simple, easy-to-use way.
Honestly, the car analogy is perfect. When you drive, you're interacting with the view level, the steering wheel, the pedals, the dashboard. You don't need to be a mechanic who understands how the engine's combustion cycles work, that's the physical level, to get where you need to go.
A DBMS does the exact same thing for data. It lets you drive without needing to be the mechanic.
But this isn't just some interesting history lesson. This system is the absolute foundation of our modern digital lives.
Yeah, this isn't just abstract computer science theory. The principles we've just walked through are running silently in the background of almost everything you do online. It's the invisible engine.
Every single time you check your bank balance, a DBMS is securely grabbing that info for you. When you buy something online, it's managing all the inventory and order details. Your social media feed, the movie recommendations on your streaming service, booking a flight, signing up for classes at school, all of it is powered by a database management system working tirelessly behind the curtain.
So this whole journey, from those chaotic, isolated files to these structured, secure databases, it was way more than just a tech upgrade. It was a revolution. It created the organized foundation of information that allowed the entire digital world as we know it today to even be possible. And that brings us to right now. We are generating more data in a single day than we used to in years. The challenges of sheer volume, speed, and variety are pushing these foundational systems to their absolute limits, which leaves us all with a final, really important question. What will the next database revolution look like?